Hi, this is Dr. Pat TV, and we're doing part two of the U-Substitution. So in the first part, I kind of just demonstrated the inverse relationship of the chain rule because that's what we're playing with here with U-Substitution. It's the opposite way of doing the derivative using the chain rule. So we're going opposite steps. Now, one of the things that we needed in order to be able to do this step was to first identify whether we have the derivative of the inside piece. Because if we don't have the derivative of the inside piece, we can't use this technique. We got to use some other thing. And so what I'm looking at here is I got an exponential. So the inside piece would be this x plus 5 quantity squared. Now, when I do the derivative of that, I basically would get bring the power 2 in front. So that would give me like a 2 times x plus 5. That would be a 1 power there. So then I would have 2 times x plus 5. That'd be like 2x plus 10. And I'm noticing that I've got a 4x plus 20. So I'm thinking I've got the derivative, at least in terms of the power. I know I've got enough power there, and the plus sign matching with that plus sign. And so here's how we play the game. So we play the same game where we're looking for the inside piece. All right, so my inside piece is going to be that x plus 5 quantity squared. And that's what we're going to call u. And that's why they call it U substitution, is because that's what we're calling U. We're gonna substitute in the letter U to make it easier. And so that's what we've got there. So the first step is to identify the inside piece. Because remember, this is the reverse way of doing the chain rule for derivatives. And that was all about inside outside. So what I'm looking at here is who's the inside piece? X plus 5 quantity squared. And then we do its derivative. And so that's what we did already. And so I get the derivative of that, the du over dx kind of thing, is 2x plus 5. So I got its derivative. All right, so that's basically what we're playing. Identify who's inside and do its derivative. So those are two steps. Identify and do its derivative. And then the next step is to substitute. All right, so here's what we're going to do. We're going to replace all of that x plus 5 quantity squared. We're going to replace it with just the letter u, because that's what we're going to call it. And so that's going to make this e to the u thing so much easier to work with. Basically it's getting rid of all that stuff that might be overwhelming. And then we're going to get rid of this dx. And what we're going to do here, oh, I got some algebra here, so you ready for this? So I'm starting off here with my derivative of the inside. What happens if I take the stuff on the right-hand side, I bring it across the equal sign and put it in the denominator, and I take this dx and I bring it up? Okay, so basically I'm doing a little kind of like a cross multiplying, but without the crossing in a way. And so I'm going to rearrange this expression so that I get du over the 2x plus 5, and then I got that equal to dx. It's going to be equal to dx, so that means I can take this dx and substitute. I can replace it. I can replace it with the du over the 2x plus 5. And so that's what we're doing. So we're doing substitution. We're getting rid of all that complicated power part there, and we're doing a substitution. And notice what's going to happen. So when we do that substitution, we're going to clean house, and we're going to divide. Notice what happened. The x plus 5s divide out. Very similar to how I showed in the previous example of the reverse chain rule steps when we divide the derivative of the inside. So that's what happens with this U substitution. We're creating the mathematics so that the x plus 5s will cancel out. The 2's will reduce out because I factored out that 4 there. And so the 2's will reduce out, leaving us a 2. And then what's left is the EU du. And so what we've got here with U substitution, the main goal is to do a substitution where everything that's left over is nice and easy and calm to deal with. I can take the antiderivative of 2EU very quickly and easily because I know coefficients come along for the ride and the antiderivative of e to the u is itself. And so what I've got here is I'm moving away from the x's by doing this substitution into like the u land, and it makes it an easier antiderivative to do. I do the antiderivative, but I don't stop there. I started with x's. I need to end with x's. So our last step in this process is to replace back what u is worth. So we substitute back what you started off with the x plus 5 quantity squared. And so that's the process. We identify what's the inside piece, we take its derivative, we do the substitution, we do the antiderivative, and then we substitute back. And so that's kind of like a 5-step process. Let's do another example of this. So I'm looking at this expression, I'm going like, oh my gosh, this is looking ugly, too overwhelming to do the antiderivative. So what I'm hoping to do is do a U substitution to make the antiderivative the easy part. And so what I'm looking at here is I'm looking at the inside here because I got parentheses and I got inside the denominator. I'm going, if I made this part the inside piece, okay, so I'm going to make that the U part, the inside piece. Its derivative is 8x. And I'm looking, hey, there's an x there. So that's telling me I've got an indication that this is going to work for me. If I didn't have that x there and the derivative had an x, they're not matching in terms of the variable, then I would not be doing U substitution. I'd be doing something else. So I got to make sure when I do the derivative of the inside, the variable piece is matching with the number of variables as well as the power. Okay, and so then basically I'm going to rewrite this. I'm going to bring the 8x down here and the dx up there, and we're going to do a substitution. So here's what we're doing here. We're going to replace the inside piece here in that parentheses with a u. So that's why we got u to the 0.7. We took that whole parentheses and we substituted it and said, get rid of all that junk, all that 4x squared minus 13. It's too overwhelming. I'm going to make it a u. And then we're going to get rid of this dx here because we're going to do kind of a little cross multiplying here, clean this up so that 8x is downstairs, the dx there. So that would mean dx is equal to du over 8x. And so that's what we got here. We got a substitution here. This is all equivalent to what dx would be worth. And then notice that the x's will cancel out, and that's our house cleaning. So we'll clean some house. We'll get rid of the x's. We'll cancel those out. We'll reduce those. We got an 8 downstairs. We'll keep that. Coefficients come along for the ride. Don't worry about the numbers, the coefficients. Worry about canceling it. We want to make sure that when this comes out, that we only have u's left over. All the complicated x's are gone. So that's the key thing here. Numbers are okay. X's were bad. We just want u's now. We want to convert complicated formula with x's into a nice, easy formula with u's. And so now we're ready to take the antiderivative. We're just doing power rule here. We're adding 1 to the power and then dividing by that new power. And so what I've got here is adding 1 here would make a power 0.3. Take 1 over 8 and divide that by 0.3. Remember, 0.3 is the same thing as 3 over 10. Flip it, multiply, and so that's where I'm getting this 5/12ths. Because 10 over 3 here, because 0.3 is really 3 over 10, then I flip it, do the reciprocal, multiply 10 over 3 here, and so 2's can cancel out. That's why we got a 5 here. That 10 becomes a 5. That 3 there, it gets multiplied to a 4, and that's where that 12 comes from. Okay, so we converted to use. Why? Because we wanted to do the antiderivative. This was a straightforward antiderivative. We've done the antiderivative. Now we just got to resubstitute back so that we've got our formulas with x's. And that's U substitution. Just trying to convert it from a complicated formula of x's to an easy formula with u's so we can do the antiderivative, and then we bring back the x's. Okay, one more example. Oh my gosh, this looks terrible. This is like, oh, overwhelming. And so what we've got here is just remember, take it easy. So in this case, I'm calling the whole denominator here, I'm going to call that my u, because when I do its derivative, the 125 is going to go away. So I knew that. And I'm left with an e to the negative 0.05x. And I just noticed, hey, in the numerator there is an e to the negative 0.05x. So that's telling me I've got its derivative of the inside. I'm not worried about the coefficients. Coefficients come along for the ride. Of course, I'm going to redo this. I'm going to bring this downstairs here and bring the dx over. So I'm going to switch the position here when I do that substitution. So what was downstairs, I'm calling that all u. So I replace that whole denominator with a u. I'm going to get rid of this dx. What was dx worth? Well, when I bring that over, bring this down to the denominator. That's why you got du over that whole thing. That's what dx is worth. And so now I got rid of my, I haven't got rid of all my x's because I still got a little bit of house cleaning to do, because these e to the x's, things, they cancel out. Got one in the numerator, one in the denominator. They're gone. Divide by 0.05. Well, when you get 1 over 0.05, that's the same thing as 20. So that's where this 20 comes from. I just worked that coefficient. The e's are gone. Oh, I got a u downstairs. I got the du. That's what's left. So I'm looking at this. I'm going, what's the antiderivative of this? This is so much nicer to look at, so much easier to deal with. Now I'm looking at u downstairs, u to the first power downstairs. The antiderivative of that is a natural log. And so then I got this coefficient coming along for the ride. I got the natural log. Then my next step, substitute back in. And so then what I called u way back when was the 125 minus e thing. I just put that back in. So now I'm back to a formula of x's. I only did the formula for u's to do the antiderivative. Once I do the antiderivative and I'm done, then I'm back here. Oh, there's absolute values around this ln is because we want to make sure that we're having a positive result for when we do the natural log, because natural log has a domain issue. It can only have results inside that are positive. And so those are three examples of doing U-substitution. I hope they helped. Just take it one step at a time. The key thing, it's the reverse steps of the chain rule, so we're still playing an inside-outside game. Thanks, and have a good day.